Today we're taking a look at two stacks from SKYSTARS that are based on AM32, or at least they should have been, and I'll talk about that a little bit more later on in the video. Anyway, what we're going to do today is take a look at these stacks. I'm going to walk you through the features and capabilities. We're then going to take a bit of a look at the AM32 configuration and explain what I meant about that should be as well. Now, just before we get on to this, I just want to say SKYSTARS did send me these stacks to take a look at for free. However, they have not paid me to make this video. They've not seen this video before it's been published. And as always, my thoughts are entirely my own. Okay, now SKYSTARS have been one of the brands that have been on board with AM32 pretty much since the beginning. They were definitely one of the early adopters and getting into AM32 before most others. Now, today we're going to take a look at two stacks. We have a full-size stack and we have a mini stack, and what I'm going to do is just give you an overview of both and just talk about the features of them and explain what these are like compared to some of the others that I might have seen on the market. Now, to start, we're going to look at the 30x30 stack. Now, this is the F722 HD Pro 4. Obviously, being called F722 means it is based off the F722 microcontroller that runs at 116 megahertz. Now, this flight controller features 6 UARTs. There are 4 PWM outputs for the motors. The gyro is the MPU 6000 and it has a baro on board as well. What's nice about this stack is it also has I2C ports as well and LED pads on the corners, allowing you to control them. Flipping it over to the other side, you will find on the back that there are dual BECs. There's a 5 volt and a 10 volt BEC on this flight controller, both rated up to 3 amp. And there's also an LDO regulator on board for supplying power to the sensors to offer the cleanest possible output from the likes of your gyro. As you can see there, we also have an analog OSD chip, so if you don't want to use it with digital, don't worry, you can still use it with analog. And there is also 16 megs of onboard black box storage located down there with a Wimbond chip. Now, looking around the board, you can see there are lots of pads available. There is a dedicated port for the digital, but everything else is padded out as well. And you've also got pads on the bottom of the board down here too. What's nice about the board when you look at it, it also seems to be some form of conformal coated on the bottom as well. It's not on the top, but it is on the bottom, offering some additional protection. One of the other nice features on this controller is the fact that you can control the BEC output with the switch on your radio. That is all done via the user 1 settings, and it's really handy if you're using it with digital VTXs, the likes of DJI 3, Avatar HD. It means number 1, you can stop it overheating, but number 2, if you're using GPS, you can actually allow your GPS to get good satellite acquisition, good lock before powering up the digital VTX. This is controlled via the user 1 settings in Betaflight, and you can simply configure it that you can have your VTX power output on a switch on your radio. Next, moving over to the ESC. Now, this is the AM60, which is 60 amp up to 6S. It supports a minimum voltage input like the flight controller of 3S. It supports D-Shot 600 and 1200 and is based off AM32, and the ESC is said to weigh 18 grams. Now, really, there's not a great deal to show you on the ESC compared to others. AM32 is flashable onto a normal ESC that supports BL Heli 32, so there's nothing specific about this ESC hardware-wise compared to, say, a BL Heli 32 ESC. And really, what you're looking at here is the quality of the build of this compared to others. What I really like about this ESC is you have individual pads for the motor outputs all the way down the sides. You'll notice that they are all wired and they are all castellated as well, and that is the same for the main power input pads as well. Again, lots of wires going through with castellation down the outside. And then obviously we have our connector up here for our flight controller. Quality, everything looks really, really good. We will get it under the microscope in a minute, but you can see there's just some touches to show that they've put thought into it. The castellation and the wires on the pads. You've got some glue on some of the components there and around the connector. And it just shows that SKYSTARS have put a lot of thought into the build itself. But what we'll do is get it under the microscope to have a look at how everything has been laid out. there you can see in the bottom corner, we've got our digital VTX connectors. We've then got our T1, R1, 5V and ground for our receiver. We've got the LED pads on the corners down there. You've got your rest of the pads there, going around there, all the way around the side, with them all being labelled for the motor outputs, and then additional pads over here. Now you've got LEDs located there as well for status. There you can see the SCL and SDA pads if you want to run a compass. There's a boot button, and then you've got your baro sensor down there, and then you've got a little jumper there to tell you what voltage output you want for the VTX. It's going to be set as 10 volt as standard, but you can change that to 5V if you needed to. If we then now just flip it over to the other side, it's going to be quite hard to show you this side because it is conformally coated. All of the light is just going to reflect off it. But you can see there we've got the chipset, the AT7456E, which is the analog OSD. You've got your WinBond flash storage. You've got some protection diodes, our back, as well as our sensors there. You can see InvenSense on that one. More voltage regulation there as well. The build quality on the board looks really good. All of the components look nicely placed. All of the pads soldered look fine. Right up there with what I would expect from any other manufacturer. Now, looking at the ESC, there's not a great deal to show you on this side of the board, although I can show you the castellation and the wires on the pads. You can see that there. You can see the wires on the pads there. It's hard to show you without refocusing. I'll put some B-roll up so you can see the castellation on the pads better, but it looks really nice. I do like the way these pads are cut out for the motors as well. If we flip the board over this side, you can see them there a little bit easier. You can see for the pads on the corners that it does go around the outside of the connector, but there is a ground under there as well, so there's nothing to worry about there. We can see our FETs, our motor drivers. It's going to be quite hard to see what the make is on these. I'll try and get that up in a minute, and again, we'll talk about that separately. But overall, with the build quality, again, all of the components look well placed, no issues whatsoever. Now, just looking at those microcontrollers, they are the AT32's 421s, and then the motor drivers is the SA6288344s that you can see there. It's quite hard to show it with the conformal coating, but you can read it. And as for the FETs, it's quite hard to show you here, but they seem to be the TPHR85s. If I just try and get the light right, there you go. You can just see it written on one of them there. Next, moving over to the F722 Mini HD Pro 2. Now, this is a mini version of the one we've just looked at. Again, based on the F722 chipset running at 216 MHz, MPU 6000 gyro, still has 6 UARTs, still has I2C, still has a baro sensor, still has analog HD, still has 16 megs of onboard black box storage, and it even still has a digital VTX connector down there as well. It has pretty much most of the same functionality as you get on the larger one, apart from this is in a 20x20 and that one's in a 30x30. It still features dual BECs, but they are reduced from 3 amp capable down to 2 amp capable. But again, that's going to be absolutely fine for most people's use cases. 5V and 10V will be fine with all of the usual digital VTX suspects. Another nice feature on this flight controller is that it does have a TVS protection diode built in as well, which should just offer some extra protection and hopefully additional reliability. Now, just moving around to the back of the board, there you can see our BECs on the sides. We've got our flash storage there, and then you've got that dedicated digital connector with some additional pads, and like the other one, we still have a USB-C for updating the firmware. Next, looking at the ESC, and this is the KM55A, rated at 55 amp, 3 to 6S input, and again, based off AM32. Now, this is a bit of a different beast compared to the first one. You will see it does have a metal heat shield over the top, which should help with cooling, but the big difference on this is that it is a single-sided ESC. There is no castellation on the pads on this because the pads do not go to the bottom of the board. Instead, you have just top-mounted pads with wires going through, and there are no pads on the bottom, so there's no need for castellation down the sides. If we then look on the main battery input, it's exactly the same. So again, there's no pads on the bottom of the board. You just have pads on the top, although you do have some additional little pads in the middle there for your capacitor. What you'll also notice on this side of the board is that the motor controls are on a separate little PCB that is mounted to the main board. You do see that's from some manufacturers. It just allows them to sort of design that part of the board separately and then mount it onto lots of different designs of ESCs. Absolutely nothing wrong with doing that. What we're going to do next is get this under the microscope as well and have a closer look. Looking at the 20x20, again, we've got the 722 in the middle. We've got our Barrow. Our OSD chip is on this side of the board this time. We've got a protection diode up here, which is the TVS diode. And then you can see we've got some basic passive components, and then you've got your pads that run all the way around the outside. These are not labeled, so you are going to need to use the website instructions to make sure you understand what these are. Flipping over to the other side of the board, again, it is conformal coated, so it's going to be quite hard to see the components, but you can see there we've got the WinBond flash storage, InventSense MPU 6000 gyro. We've got the voltage regulation circuits on each side as well. And then you've just got 3 pads over there alongside our digital VTX connector. Down there, we also do have our control for our back on our VTX. You've got the pit and the 5 volt, and that's exactly the same as what we saw on the big controller. Looking at the ESC, you can see the pads there in a bit more detail. We've got the wires going through on the edges as well as some wires further up on some of them. As it is single-sided pads, there isn't a lot to show you on this side, but you can see that there are some traces down there, but they're not solderable. All the soldering is on this side here. As I've said, because this doesn't have the pads on the bottom, there's no castellation. It's exactly the same on the power pads as well. As you can see, we've got plus and minus there with wires going through to help spread the current on the other side of the board. Now, just looking on this side, just to show you the design. So we have a couple of FETs here and here on the bottom side of the board. We've got our voltage input and regulation area there. And then we've got our main motor drivers down here. So you can see, there you go. You can see the AT32F421s for the microcontrollers. You can see that one there, there, and there. And then we got some motor drivers there, which look to be labeled SA6288408s. And obviously, as I've said already, these are all on a separate PCB that solders to the main PCB. Absolutely no issues with that at all. Soldering on the connections looks really good. Yeah, don't see that causing any problems whatsoever. Finally, just moving up to this side of the board, you can then see our ESC connector. There's no pads on the bottom, but there are pads on the top for the ESC connector if you did want to hardwire it. Now, just to show you what else you get in the box with the flight controller, because I haven't actually covered that yet. I'll just try and get it out. There we go. In the bottom, you get this little box, and included with this is... Let's get in. We've got our power cable. We have a capacitor, so they've included a 35 volt 1000 UF, so it's a nice size, that pretty good. And then we've got a plug and wiring kit with some bolts for our stack mounting options, basically. So everything you need to get yourself up and running. Now, the next thing I wanted to do was walk you through a bit of the overview of the configuration of AM32. And whilst we are still going to do that, it was at this point in my testing that things went a little bit sideways and I found something that was rather unexpected. And that was as follows. The KM55A ESC that I received is a model that would traditionally come with BL Heli 32, but obviously as a result of the issues around that, it is now shipping with AM32, and that is absolutely fine. Where things were a little bit strange was with regards to this, the AM60, which is an ESC labelled AM32, but the one they've sent me has actually come installed with BL Heli 32 installed. Now, this is a fully legitimate copy of BL Heli 32. It is not one of the test versions. It is version 32.10 that officially looks like it's licensed. There doesn't seem to be any quirks around it whatsoever. However, that is not what it says on the front of the ESC. Now, I do want to state that I was sent early release versions of this hardware, and as a result of that, it seems there's been a bit of a mix-up. Unfortunately, though, I am not the only person to have had this, and there are a few posts around social media and Discord of users facing the same issue, buying an AM32 ESC and getting BL Heli 32 installed. Whilst this is unfortunate, I will add that the version of BL Heli 32 that I did get on this ESC is fully legitimate. It is not that test copy that we saw some other manufacturers ship. It appears to be a fully licensed copy, so in the end, I'm technically no worse off. I've got an ESC with legitimate software, but it isn't the software that it says on the front. That isn't to say, though, you couldn't flash this to AM32, and I'm actually going to do a video walking you through how to do that later on the channel. But as I am always open and honest on this channel, and other users have also faced this, I did want to highlight the fact that this has happened, and it has happened to other people as well. But SKYSTARS are solving this for people, as I understand it. If you do get an ESC with the wrong firmware and you want to have what it says on the front, just reach out to them and they should swap it out. Now, what I'm going to do next is just give you a quick overview of the options that are available within AM32 if you haven't seen them, and then I'll come back and share with you some thoughts on the hardware itself. Now, one of the great things about configuring AM32 is the fact that you don't need to install any software on your computer. You can go to am32.ca and use their web-based configurator that allows you to do all of the configuration on your ESC. You can also use the ESC configurator page. This not only supports AM32, but it supports BL Heli S and Blue Jay as well. And this is probably the most widely known and used method of configuring your ESC. There is also an app available for your PC as well if you want to use that offline. However, this isn't quite as smooth or as easy to use as the web-based configurators. Now, to connect to AM32 is fairly straightforward, pretty much the same as it is for BL Heli. What you first of all need to do is select your port. So as long as you've got it connected via USB, you should be fine. If you do have trouble here, just make sure you have got Betaflight closed, because if Betaflight is open in the background, it could override the serial port connection. We're then going to click connect and then read, and this will then connect to the AM32 ESC, and then you'll see everything pop up on the display. Now, looking along the middle, the first thing you will see is each ESC has been read in. We have information in here such as the bootloader, the MCU and the firmware type, and you can see that for each ESC as you move along. Below this, we then have some options for each ESC, so we can reverse the motor output on each one independently, or we can enable 3D mode independently as well. Scrolling further down the screen, this is where you get to the rest of the main settings for AM32, and at the top of this there's a real important one which I think is actually a great thing that you have in AM32, and that is the ability to manually set the protocol. The way it worked on BL Heli was the protocol was detected from the flight controller on connection based on the communication types, but this wasn't manually settable. However, here in AM32 you can, and the great thing about this is it reduces the possibility of things like accidental spool ups as a result of the ESC misconnecting to the flight controller and picking up the wrong protocol. This means you can actually manually set the protocol that you want it to use for each ESC. Scrolling down from here, you then have the more advanced options. So under motor, we've got things such as stuck rotor protection, stall protection, Hall sensors, variable PWM and complementary PWM. You've got your timing settings, your startup power, your motor KV options, motor pole options, beeper volume and PWM frequency controls over here. Under limits, you've got things such as temperature limit, current limit, and you've got low voltage cutoff available here as well. Then you've got sinusoidal startup if you want that option. We've got braking options, and then further down you've got servo settings such as the low, the high threshold, the neutral and the dead band if you wanted to use it with PWM. Overall, everything under here is really nice and straightforward. About the only things you do need to do when you first set it up is set your protocol. I personally set it manually, and then you want to make sure you got your motor KV right, your motor poles right, and if you want to adjust your PWM, you can, but you shouldn't need to change that from standard. Now, I'm going to end this video here. I'm going to then make another video where we're going to flash this to AM32, and then I'm going to be talking about some of my experiences with AM32 once I've done a bit more testing. Just going over some of the things that we've seen today. With regards to the quality of the stacks, the hardware is really, really nice. I like the work that SKYSTARS are doing. The reports from the community on the SKYSTARS hardware is really good as well. People say it's some of the best and most reliable hardware that they've used. In fact, ESCs especially seem to be pretty much bomb-proof. I also like the features that have been integrated into AM32, and the big one here is the ability to be able to set the protocol, which means you can take away some of the risk of your flight controller and ESC miscommunicating that could potentially result in a spool up. This very issue was a problem on earlier versions of BL Heli 32, and whilst they did solve and mitigate this, I much prefer being able to just say, hey, I want to use this protocol, and take away specifically that risk altogether. Now, if you're interested in seeing some of this hardware for yourself, there will be a link to the SKYSTARS website in the description. I want to say a massive thank you to them for sending this over. As I've said, in part 2, we're going to take a look at flashing the ESC to AM32 and walking you through that process. Now, if you've liked what you've seen here, please do let me know below. If you have any comments or questions, let me know as well. And also, if you'd like to support the channel to allow us to keep making content, please do consider check out the link to my Patreon as well as buy me a coffee. It is only through the support on my patrons I'm able to keep making content on this channel, and if you'd like to support us to allow us to keep making content in the future, please do consider checking it out. I want to say a massive thank you to all of my Patreons. We would not be able to keep doing this without your support. Anyway, that's it from me. Stay safe. I will speak to you soon.